Data collection procedure. So I'll be running through the initial data collection steps too. This includes what you can do before going out in the field, including collecting any background information, getting your field gear ready, and then what you do when you get to the assessment site. So the desktop Recon, this is important, especially if you are working on an assessment reach near a border of one of our regions. So it'll help you determine what you want to collect in the field, what you prepare to collect in the field. If you're near, for instance, Great Plains border on you and the Southeast, you may want to bring be ready to collect some extra indicators that are associated with the Great Plains. That way you'll be able to apply that method as well. You'll want to do the recon to get background information about the site, including getting landowner permission, knowing the property boundaries, having taken care of safety concerns, and knowing the recent and expected weather for your assessment visit. You can also get an idea of the channel size, so you can anticipate your reach length and number of assessment reaches that you'll need. So that way you can plan out the time in which you're going to be collecting information. You want to be pulling together any existing hydrologic and biological data that will help support your assessment. In some cases, you can estimate some of the indicators from aerial imagery of the site. This is probably less likely in forested areas than in a more open reach where you can see the channel more clearly in aerial imagery. So that way you can get an estimate of the reach length from getting an idea of the width of the channel. Lastly, you can identify local resource managers who can tell you more about the site and nearby streams. Historic imagery can be helpful for providing snapshots of flowing conditions at different times of the year. Google Earth can provide imagery dating back 20 or 30 years. So multiple images over that time period. They can tell you about the land use, roads, access points, sources of flow, extent of riparian vegetation. Note that although the dates are reported in Google Earth can be sometimes inaccurate because multiple images from different dates are often stitched together for display. The date of the particular portion of the image may differ than the display date. But zooming in will make the date more likely to be accurate for that area that you're viewing. You can check the source of the image at the bottom center of the screen where I've got those red circles highlighted on Google Earth. And if necessary, these dates can be verified using USGS's Earth Explorer, which is another source of aerial imagery. The field gear for the SDAMs are pretty standard for stream sampling and can be carried by a single person. The largest item you'll be carrying is like a D-frame net to collect aquatic insects, though in smaller streams, even an aquarium net might work well. Some pieces of equipment listed here are only for the Southeast or Northeast regions. So those are shown here, such as the sand gauge card for characterizing particle size, clinometer for slope, densiometer for canopy cover. Those are only used for the Northeast. Some of these are just regular gear that you would bring on any field visit, like waders, first aid kit, those kind of things. So a lot of these things are pretty standard. One reminder is to please clean the gear between sampling different locations to avoid spreading invasive species or fish and amphibian diseases. Um, there are USGS and USDA resources to advise on how to clean your gear and how you can report observations of invasive species when you do see them in the field. When you get to the project area, you'll want to walk the entire reach to determine if more than one assessment reach is needed. Look for any natural or artificial features like tributary confluences or effluent or stormwater pipes that may abruptly change flow duration. As you start walking up your reach, start collecting bankful width measurements at 3 locations to estimate your reach length. Remember, we want 40 times the bankful width, or a minimum of 40 meters, maximum of 200. If possible, avoid walking the entire reach in the reach, as disturbing the channel will affect your ability to measure or observe indicators that you're collecting. Though not among the indicators used in the beta dams, the initial walk is a good time to note any supplemental observations like the presence of fish or amphibians that can be easily spooked by you or your shadow. Finalize the reach boundaries so that you can find the area over which you'll be characterizing the indicators and where you'll distribute sampling effort for aquatic invertebrates. Then you'll want to sketch out your reach so that way you have it well described, noting the upstream and downstream boundaries and where various channel features are located. And you will also then be able to note where you might see standing or flowing water in the reach. So we measure bankful width in at least 3 representative cross sections to determine the assessment reach length, as well as using it as a geomorphological metric. Bankful stage can be difficult to determine in some settings, but is essentially at the transition between the channel and the adjacent floodplain or hill slope. There are a number of different indicators that can be helpful in identifying bankful elevation. Obvious break and slope is one. Elevation of the highest depositional feature, such as a gravel bar, and transition from exposed sediment to a mature terrestrial vegetation is another common indicator used for bankful elevation. Once you decide where the bankful elevation is, then measure the width perpendicular to the channel fallweg from bank to the nearest 1/10 of a meter. For multi-threaded reaches, measure bankful width across the entire channel. We're not measuring wetted width, so this would on the photo shown, it would span the entire bankful width elevation, not the wetted width. There's a place to record general site information on our field form, like project name or site code, coordinates of the reach, which you'll need to acquire the average seasonal precipitation metric, as well as drainage area. And descriptions, there's room there for descriptions of the reach boundary. Sub-meter accuracy is desired when you are working near confluences to acquire your coordinates, or in basins with a high drainage density. So that way you can make sure that the reach that you are applying the assessment to is not on a larger downstream main stem when you're working near a confluence. In those situations, you want to be certain that your coordinates are geospatially accurate. There's also a place where you can be recording surrounding context of your assessment. That means weather conditions, land use, any disturbances you might observe that might affect the flow duration or your ability to measure the indicators accurately. An example might be there is evidence that the channel has been recently dredged or rip-wrapped or restored. Documenting or confirming nearby roads, buildings, or other features will help you corroborate your spatial location of your assessment reach with the coordinates that you captured in the field and recon beforehand. So that way, when you do calculate drainage area with stream stats or the national map, you will be certain that those coordinates are accurate based on where you observed and took notes of other features around you. Photos are really helpful for documenting flow conditions during the assessment, as well as indicators and features or disturbances that might affect flow duration or your ability to observe indicators. We strongly recommend taking photos of the reach from different perspectives, upstream, downstream, laterally. We also recommend taking photos of individual indicators or other supplemental information that you see. This is particularly useful for confirming identifications of things like upland plants in the channel or macroinvertebrates. The field form has spots for logging photos of different indicators and features, and the web tool will have places where you can upload photos to the associated report as well. The next thing that's helpful to record is the specific characteristics of flow condition at the time of the assessment. Three characteristics include the percent of the reach length along the fall wag with surface flow, and the percent of the reach length with subsurface or surface flow that can be greater, and it can be greater than the percent with surface flow um, when the channel has discontinuous surface flow. These can be measured directly with a tape measure or estimated by walking the reach. The third characteristic is the when you have a mostly dry or discontinuous flow in the channel is the number of isolated pools. Isolated pools are only those pools in the channel that are holding surface water and has no visible connection to surface water. In the examples to the right, the first three lack isolated pools, but the last one has an isolated pool.